Hello friends, welcome back to my channel. Today I would like to share with you the topic states of matter. First of all, let's look at kinetic particle theory. The main points of the theory are: all matter is composed of tiny moving particles invisible to our eye. The particles move all the time. The higher the temperature, the faster they move on average. Heavier particles move more slowly than lighter ones at a given temperature. And this shows the particle arrangement and movement. Solids, liquid, gases. Closeness of particles for solid very close, liquid close, and gases far apart. Arrangement of particles: solids are regularly arranged in a regular pattern. Liquid randomly arranged, gas also randomly arranged. Movement of particles for solid: vibrate around a fixed position. Liquid move around each other. Gas move quickly in all directions. Energy of particles of solids have low energy, liquids greater energy, and gas highest energy. Next is the properties of solids. They have fixed volume and shape and have high density. They vibrate in position but cannot change the location. They are packed very closely in a fixed and regular pattern. They cannot be compressed or squashed because their particles are close together and have no space to move into. Properties of liquids. Liquids have fixed volume but adopt the shape of the container, generally less dense than solids. An exception is water, but much denser than gases. Particles move and slide past each other. Liquids cannot be compressed because their particles are close together and have no space to move into. Properties of gases: do not have a fixed volume and, like liquids, take up the shape of the container. They have very low density. Since there is a lot of space between the particles, gases can be compressed into a much smaller volume. The particles are far apart and move randomly in all directions. They collide with each other and with the sides of the container. This is how pressure is created inside a can of gas. This diagram shows changes of states from solid to liquid, liquid to gas, and gas to liquid, liquid to solid. Solid to liquid is called melting. Liquid to solid process is freezing. Liquid to gas, the process is boiling, and gas to liquid, the process is called condensing. And the solid changes directly to gas, gas to solid, is called sublimation. So let's see the changes of state in terms of kinetic particle theory. First, let's focus on melting. If energy is supplied by heating a solid, the heat energy causes stronger vibrations until the particles eventually have enough energy to break away from the solid arrangement to form a liquid. Change of state in terms of kinetic particle theory for boiling. If more heat energy is supplied, the particles eventually move fast enough to break all the attractions between them and the liquid boils. Change of state for condensing in terms of kinetic particle theory. If the gas is cooled at some temperature of the gas, particles will slow down enough for the attractions to become effective enough to condense it back into a liquid. Again, as those forces are re-established, heat energy is released. Change of state freezing in terms of kinetic particle theory. When a liquid freezes, the reverse happens. At some temperature, the motion of the particles is slow enough for the forces of attraction to be able to hold the particles as a solid. As the new bonds are formed, heat energy is evolved. What happens when we heat a solid? In a solid, the particles are held in a regular structure. They don't move away, but they do vibrate to and fro. When you heat it, particles take in heat energy. The vibrations get larger and stronger, so the solid expands a little. When you give more heat, the particles vibrate so much that the structure breaks down. The solid melts to a liquid. The particles continue to take in heat if you heat more, and they continue to take in heat energy, so they move around more, so the liquid expands a little. Some particles gain enough energy to overcome the forces between them and escape. This is called evaporation. And if you heat again at a certain point, all the remaining particles gain enough energy to escape. Then the liquid boils to a gas. Evaporation is sometimes confused with boiling. They both involve liquids turning to gases, but evaporation is different because it occurs at any temperature, not just the boiling point. It only happens at the surface of the liquid, not throughout like boiling. Boiling requires an energy input, whereas evaporation is the release of the molecules with the highest energy. And sublimation, when a solid changes directly into a gas without going through the liquid stage. This happens to only a few solids such as iodine or solid carbon dioxide. Heating and cooling curves in terms of kinetic particle theory. A heating curve is a graph showing the temperature of a substance plotted against the amount of energy it has absorbed. You may also see a cooling curve, which is obtained when a substance cools down and changes state. This shows the heating curve of water. In this, as you can see, ice, when it gets heated up, it changes to water, and then after heating again it changes to steam. So as you can see, at 0 degree ice melts, so that region represents the melting point. It's a horizontal part. Similarly, at 100 degrees Celsius, you see the water boiling. That's called the boiling point. It remains constant until all of those has changed to steam. And after 100 degree, it's steam. And this is a cooling curve of a substance. As you can see here, it starts from gas and it is moving to the liquid and then to solid. Gas to liquid changing phase is called condensation. It's a condensation point. It's constant over there. That's representing the horizontal region. And then it becomes liquid. Then it changes to from liquid to solid. It's called freezing. And that's a point which you can see over here. It's a horizontal region which doesn't change until all of the liquid changes to solid. So then after that it becomes solid. And this is an example of a heating curve for naphthalene, which is a pure substance, as you can see here. And the next one represents the heating curve of a mixture, which is a wax. What is the effect of impurity on melting point and boiling point? Pure substances have definite, sharp melting and boiling points. The presence of an impurity in a substance lowers the melting point and raises the boiling point of the substance. The effects of temperature and pressure on the volume of a gas in terms of kinetic particle theory. Gaseous particles are in constant and random motion. An increase in temperature increases the kinetic energy of each particle as the heat energy is transformed to kinetic energy, so they move faster. Decreasing the temperature has the opposite effect, so the particles slow down. As the temperature increases, the particles in the gas move faster, impacting the container's walls more frequently. The pressure that a gas creates inside a closed container is produced by the gaseous particles hitting the inside walls of the container. So when there is an increase in temperature, this also causes an increase in gas pressure. Diffusion, movement of particles from an area of high concentration to an area of low concentration, is called diffusion. For this to work, particles must be able to move. Therefore, diffusion does not occur in solids. Since the particles cannot move from place to place, it only vibrates. A smell does not travel very fast because the particles collide with particles of air, changing direction randomly when they collide, taking much longer to travel from place to place. And diffusion occurs much faster in gases than in liquids, as gaseous particles move much quicker than liquid particles. At the same temperature, different gases do not diffuse at the same rate. This is due to the difference in their relative molecular masses. Lighter gas particles can travel faster and hence further, Therefore, the lower its relative mass, the faster a gas will diffuse. This is an example for that. Reaction between ammonia and hydrogen chloride. Aqueous ammonia gives off ammonia gas. Hydrochloric acid HCl gives off hydrogen chloride gas. If you set up an experiment like this, you will get a white ring of ammonium chloride forming in the glass tube. The ammonia gas diffuses from one end of the tube and the HCl gas diffuses from the other. When they meet, they react to form ammonium chloride. The ring doesn't form exactly in the middle of the glass tube. It forms nearest the end of the tube where hydrochloric acid was. This is because the particles of ammonia are smaller and lighter than the particles of hydrogen chloride, so they diffuse through the air more quickly. That's all. Thank you so much for watching this video.